Just because I love geometry and this problem was clever, I thought I'd throw this together. So this problem is at its core really only about these two triangles. This space here is kind of a red herring. But as we do often in proof, we start with the givens. So I'm going to put in that given. I put a little purple dot next to it to show that when I put in these lines, you can see that the purple lines are what we've claimed are congruent based on the given information. Then we'll put in those angles that are congruent, and I mark those with blue. And now the third piece of information suggests that these two angles are in some way related. We can't actually mark them as congruent yet because we weren't given that they were congruent. We're given that they're perpendicular. So step one is to say that they're perpendicular. Step two is to say that means they're right angles. The definition of perpendicular is that they form right angles. Once we have that they're right angles, you could either say they're congruent because all right angles are congruent, giving us now that these two lines indicate these two angles are congruent, or I'll show you there's another way to do that in a minute. And those three pieces of information, this angle pair, this side pair, and this angle pair is enough to show that these two triangles are congruent by angle, side, angle. And that then lets me establish that if the triangles are congruent, any corresponding parts of those triangles, CP, CTC, are also congruent. And again, the other piece would be to say that these two angles are right angles given. That means that they make right angles, definition of perpendicular. Then say the definition of right angles is that they're 90 degrees. Then say that by substitution property of equality, they could be set equal to each other. Then by the definition of congruent angles, you could say if they're equal, then they're also congruent. Either way works. Anyway, good luck.